Yeah, today this topic is regarding Tarjans algorithm. So in this algorithm, basically we will try to find out strongly connected components in a directed graph using this algorithm. So coming to the topic, basically the main issue for finding strongly connected components is for like to find out the strongly connected components here. So if you come here, so 2, 3, 6 and 7 is one SCC and 4, 5, 8 is another SCC and 1 is another SCC. So in directed graphs, basically we have to consider always the the iteration order actually, because like basically if we come to an example here, if you can see the images, so from starting 0 and like if you are trying to do DFS, so basically you can see like 0 1 2 0 1 6 like are going, but we can let's the 0, you can see 0 0 0 as their low link values, but when you take this 0 as this position, then here if you do DFS you will be always getting low link values 0 for all of the things, which is wrong in directed graph. So the main thing is here we have to take a different array, which is nothing but sorry, insertion order, iteration order. Hmm. And also we take a array which is the position or the time at which we are starting the DFS on this. Okay. Or time at which DFS reach. Okay. So this is the first array which does this. Other thing is the low array. Low array is basically uh, the lowest value which a node can reach. A node can reach. Yeah, so as you can see here, like if in this case, like 0 1 6 are having low value as like 0 0 0, like okay. So how are we going to find out like a CC in this? Like basically, whenever we are having, whenever we are doing DFS and like on reaching the DFS, like on reaching the same node again, like how are we going to find out the same node again? So here we will be using stack stack which stores the current DFS path. Okay, good, right? Yeah. So in this stack, what we'll do is like on every DFS is going to start, we'll be pushing the node onto the stack, and like on iteration, like for example, if in C in this case, so 0 to we are 1, we are going 1 to 6, we are going again. From 6 we are going to 0. Okay, so as you will see here, like uh, 6 is going to 0. So when we will find again, we are going to 0 again. So in this case, um, we will be knowing that 0 is already visited, so we will be coming back in the iteration. While we are coming back, we will check like the lowest link value of the 0 and 6 0 value. Okay, so I mean like instead of finding the lowest link value, because this low link value can change like different times, what we'll try to do is like when coming to again the same node, so then we'll try to see the position value, that means the time at which the DFS has reached or started on this node with the 6. Okay, so 0's position is 0 and 6 low value is 6 basically, because like initially we are making uh, position and low as same value. Okay, so then low value of the 6 will become 0, and the same again when we are coming to 1 again, it will come to 0. 1 also it will be 0, and when will be coming to 0. So in this way this will be happening. So what will happen is like in this case, one thing is In this case, one thing we have to do is something I am missing. Okay. Yeah. So this logic, what we'll be doing is here, like, if whenever, like, in stack, okay, in stack, we will pop if the position and low are equal. Okay. So if in stack, if the position are equal, and then we will pop out all the elements in this. Okay. So this is the thing. So now other thing is, like, you might get one other doubt, like we will going to another scenario where what we are going to do is, uh, so in this I'm opening for a scenario. So in this scenario you can see in this G H I and G, G H J and I. So if you see, there's a thing here. You might think for H I J will again, we will be thinking like when we are doing like uh, DFS, you can see in GH HIJ is also there's a other loop in GHIJ. Okay, so what we going to overcome this? So what we'll be doing here is like, as firstly coming to the J. So when J goes to G, so it will check like G is already visited. If the iteration is started at G, so let's think iteration started at G, so it will go to H will go to I will go to J. So again J will go to G, and it will see if G, J and G are like okay, G is already visited, so I will take the J's low value as a G's visited time. Okay, and then again what I will do is like, again I will go it's another child, it is nothing but H, and H is also again visited. So however, in H we will see that H low value is what? H low value is H, low value is H only, because like it is not yet backtracked now, right? Yeah, so now J's low value is nothing but G, and it's compared with H. Okay, so H low value is H only. So when compared to this, G is low. So J's low value will be G, and again on backtracking, I's low value is also J. I's low value will also become G, and for H also the same thing. So in this way, the main point what I want to tell is like, we will be doing this logic of popping the thing from the stack on coming back. On coming back is nothing but backtracking. I mean, after finishing all its child nodes. Okay. So yeah, this is the thing. So this is how we will do uh, Tarjans algorithm, and there might be unconnected components. Like for example, uh, in this example, if there is an other array, like, sorry, I mean other tree, like other graph, like let's think some, let is in the 9 and 10 is there. Okay, whereas again this is nothing but it is there like this. Okay. Okay. So here what I'm saying is 9 to 10 only. There's another listing. This is one connected component. This is one part of the graph. This is the other part of the graph. This will make a full graph of unconnected things. Let's think like that. So what I will, so to overcome this, again we have to write all the logic which we have decided in a for loop. So basically now I am writing this. What do we say, that pseudo code? Okay, basically pseudocode. Why I am writing pseudocode? Because I have already tested this. So I am not writing the Java code, but we will be discussing with a question of critical connections in a network. Okay, which is also based on this itself, like this logic itself, like almost Tarjans algorithm only. So in pseudocode, what we are doing is like pseudocode. First thing what we have to do, we should initialize arrays. So initialize arrays. What are the arrays present? Low array. Okay, low. Other one is what? Position. Okay, now other one is what? Okay, these two are enough, and we are going to initialize in low cost to -1. Okay, now on for loop of for every for each on every node start, and also one variable is like uh, num variable. Okay, num variable is basically 0. Let's think. Now for every node, what I will do is basically this node on every node, what I will do is like I will do one DFS. So in this for every node I will do is like if I'll check if okay main first we will do this. Okay, in DFS what we will do is like basically no DFS is not nothing but a method here. So in this method what I will do is like the whole algorithm I will send to this. Okay, now what I am doing into this like in this method what I will do is like what I will do is like low and low equals to position basically. Okay, which is equals to num plus plus. Okay, this is one thing, and low is equals to position equals to num plus. Okay, after doing this what I will do is like now what I will do is like for this DFS now okay what I will do is shift this. Okay. Low అనేది position first low of this is nothing but low of what I do is TFS method. Just a second. What I want to do is like I want to do the DFS. While doing the DFS, all I will do is like if it is a abstract thing or not. Okay. See, this way to go we keep the separate one. Okay. DFS of low position. Make this a stack also. And apart from this, like basically the new things I'm saying, like since which are so in this DFS basically what I will do try to do is like low one person on position one person stack one person. So low position stack వెళ్తున్నప్పుడు నేను ఏం చేస్తున్నా ఇప్పుడు like this DFS what I will for each on each node, I mean again on this child, what I will do is like so that I'm like okay. For each of each child, so for each on every child, what I will do is like so for each on every child, what I will do good morning for each on every child, each child. So what I will do visited. Okay, child is not visited basically. Not visited or nothing, but child's position is null, is -1. Only then we will do. Okay. ఒకవేళ child position -1 ఉందనుకో, then only can go with. Okay. That by -1. Other than this, we have to do one thing. Other is other one thing. Child position is -1. That means child is not visited. Okay. Child is not visited. That means DFS of child. Okay. So if child position is not -1. Okay, that's what child is visited. If I goes to -1, I else when in trial. Child position is not question -1. Stack dot contains of child. So in this case, what we are going to do? In this case, what we are going to do is like DFS. That means it is already listed in law of present node equals to position of low child, because we are saying child is already listed, right? Going to stack. Okay, so position of child and position of child and low of child. Low of child. So this is the low is okay. Instead of stack contains, we can take a stack as a stack array. This stack array. Okay. In stack. Okay. In stack array. Which is also -1 basically. Yeah, like in stack of child. Okay. Now law of present and then I will do this. Now if this contains like this only. If child position process it, not equals to -1. Here also we will get back. Now here what I will do is like law of present node will be equal to QoS of not pure, just in this case only low is needed. Law of and law of present node. Okay. And this is for level thing like okay. Level chart we have to do like so. Because using file. We do for every child this will happen for all the child, and only then we will come back. Okay, so because here what will happen is like for example let's see for 1. In the example 1, so 1 will go here and one child is for every child of the 1. 1 will go 1 gets initialized here, and one JFS method will be called, and one JFS method for 1 it will see its child it will see child. So in that child position is -1. Okay, yeah, basically they are in channel -1. So again we are going to HDFS, and here what I will do is like we will go to the thing called tap is present in 3 only. Okay, this loop is present. So again it will go to 3 only. Okay, it will go to 3. I will come again for this 3. For 3 it will go to this 4. Sorry, it will go to 7. Oh, sorry, a wrong notation. I mean 3 to 7 here. Okay, not 7 to 3 to 7. And this like okay, the generation inside this. So here like 3 to 7 to 3. It is not to 7 to 3. It is 3 to 7. Okay, 3 to 7. This should be like this. Okay. So you understand. I'm saying this for you itself. Okay. So so, so 3 to 7 we are going right. Okay, 3 to 7 and 7 will go to 6 and will go to 6. When 6 will go to 6, we'll see this position is not -1 and stack of this is equals to 1. That means only that means yeah, then this condition will be worked out. Okay, so now the thing is here, the main thing is like what we are soon doing is here one thing you have to remember is we're going from 6 to 2. Okay, and then after do nothing is there, so we will return back basically. Okay, that is the thing here. So we are not doing the stack part. So like I and we are like why if else if is used, else we are not we are doing if else if, because like there also other condition which is nothing but else. We are between at what any nothing but like if what do we say, let's think there is some notation from 6 to 1. Okay, basically 6 to 1, or else like think 6 to 9 it is there. Let's think 9 is 10 and 9 and 10 are already passed. Okay, then in that case instead of passing them again, so what we can do is like we can happily yeah, we can happily basically yeah, we can happily I'll say that like 9 and 10 is already done, so do nothing with that. So that's why else case. So they don't need to do anything in that case. And don't confuse like see in this case you might think if I start at 2, it will go to 3, 7 and 6, right? So low link value for all this is 2 only. Don't think for 4 also it will be 2, because what we are going to write condition is if, see we will do that condition if, so after this parsing is done for every child, we will do in if stat yeah, if low and I ask you low and position are equal, if low and or position are equal for a node, like until this thing is like uh, are equal of the current node. Okay, of current node. Then I have to sir banne bro start dot pop start dot pop. So here we are going to do stack dot pop till this current node is met, till present node is met. All these things are all these elements are added to list. Okay, yeah. So in this way we are going to do SCC. So for single case what will happen is for here like for one if you see for 2 3 6 7 will be SCC, right? After they are getting returned again one, for one case you will see that for one also position and lower same. So one is only removed and it is added a subtraction list. So in this way low link value for Tarjans algorithms works in this way basically. And second thing is you have to know another course is critical connections in a network. Critical connections in a network are in a network. critical connections in a network is basically what the thing is here is like uh, 1 and 2 are critical connections and 3 and 4 are critical connections, and yeah, only this, because if we remove this, like these strongly connected components will get apart, like they will be divided. I mean, yeah. So now how are we going to find out? So if you see, to find a critical one logic in this we have seen is like for one low link value is 1 only, but for this it is 2. Okay, for again 4, 5 and 8 it is 4. So while we are returning, I mean, while not only while we are returning, if if the low link value of the returning one and the present one are basically child and a parent, child is more than parent basically. Okay, not I mean, uh, instead of low link value, you can think the you can consider it's better to consider it's, what do we say, this three's uh, position. I will. Hmm. For three's position, we are taking. We are going to compare for to connect find out critical connections in network. In backtrack, uh, if child and child low value is greater than present node position value, then it is a critical connection. So we are going to see the code of it. Okay. So we are going to see this. So this is another question. Don't leave this. Just for an idea, I'm telling this minimum cost to connect all networks is using an minimum spanning tree. We are going to make another video on this. Okay, this we are going to do with critical algorithm. Yeah, coming to our question. Critical connections in network. Connections in network. Lead code. Okay. So this I have done that. Today is, you can see, is 4th December. I lost my job and luckily. So yeah. So if you see this, like position low, and the main list is nothing but the answers in which we are going to store our answers. Okay. We'll be getting just connections, and we are going to create a adjacency list from this. Okay. So and after getting adjacency list, I am initializing with -1. For this, next what I'm doing is like, yeah, as we said, like position is not equal to -1, then we are going to do the DFS for this. Yeah, so in this again, like initialize, we are basically initializing this to, yeah, low and position are being initialized. Yeah, we can initialize this thing here as well, basically. Okay, and as we have to do it for every DFS, so we are placing this in this within the DFS itself. So for every child of that present node, so what we are doing is, if as we said, the two conditions mainly only for if child is already visited or not visited. Okay, and if, I mean, if it is visited, if it is in stack, basically, then we will be doing, or else like we won't be considering. But in this case, as it is a, as you can see in questions, this is basically for a non-directional graph, so there's no need for having this that thing, like as we say, as we were discussing. Okay, we're going to position child and child. Yeah, no need to see that if it is in stack or not, because in this question it is mentioned that it is only one. I mean, like, yeah, there can be more than one unconnected components, but basically for as it is an undirectional array, so even if you are going to start from 0 or 1, all the edges and all the nodes will be covered, child nodes will be covered, like, yeah, based on the iteration order, where we can even anywhere we can start, but we can reach to any node within one traversal. Yeah, in directional case it's not possible. That's why here only we are saying if position and child not equals to parent. Like what we are trying to do is, like, because in this unidirectional graph, yeah, like because we are going to come from 3 to 1, right? Again, if it should not be from 1 to 3. That's what we are. Except that we have to see for if in this case it should see for 1 should see for 0 and 2. For example, if we are going to start with 3, yeah. So then what we're doing, method mean of position of child and law of child. As we know, this position of the child, we are checking and law of n. Nothing but here, as you can see, for the child, if it is already visited, then the child's position should basically be uh, yeah, the minimum of the position, child's position, and the minimum of the law, which is which often. Yeah. Then if this is not the case, like if it is not visited, then we'll be doing the same thing. We'll be doing the EFS side. Again, we'll be doing like law of the both. And if law of yeah present is less than law of child, yeah, as we said discussed, here we are checking C. So law of n is less than law of child. Then main list dot we are adding this. Yeah, law of n and law of child. We will be seeing the what are the submitted solutions here. Like submissions will go to our submissions here. The first submitted code. So if you see here in this, so you can see here for guarantee we are seeing this. Okay, child name, law of basically, and present node. One node we are taking the law of child name, law of name. Okay, this is fine. Okay, and then child node equals to parent. Go to which position of child's position of nth value. This is to the checking solution. It's for Java. It's not a of the present and the hiding the this thing. Okay, that means like yeah, okay, we are considering the law of the present and position of the child. Yeah, so this is it. Now we are going to